Hi, and welcome to this Lernard.com Ansible section on variables. So far in this chapter, we've covered modules being applied to servers via SSH. We've covered tasks calling those modules, and we've grouped those tasks into specific packets of functionality called roles, which we're in turn calling from a playbook. We're now going to make this model even more useful by taking a look at the familiar concept of variables. For those of you who are veterans of the Terraform chapter, you'll probably remember that there are a number of different places in Terraform that variables could be applied, with an order of precedence describing which value would be the one used. Ansible works in a conceptually similar way to this, where variables can be defined in a number of different places with different scopes. When I started making this section, I expected it to be quite short, as variables are simple to understand, and I'm guessing most of you will have been familiar with them before even starting this course. I was surprised to find that it's ended up being over 20 minutes long, because though it's easy to understand conceptually speaking, there's just so many different ways to use them in Ansible. I've tried to keep my examples as brief and concise as possible, and I'll try not to dawdle too much on any concept. So with that in mind, let's jump over to our Ubuntu VirtualBox VM to get started. As always, for anyone who hasn't been following along creating their own code, remember you can download all the code you see in these courses at the Lernard GitHub page, and there's a link to that at the bottom of this player. For the rest of us, let's do the usual drill and browse to our Ansible repo, list the contents, make a copy of section 4, and call it section 5. And there we have our new section 5 folder. Now we've done that, let's cd into the Terraform folder and spin ourselves up the servers we're going to work on. As before, if you're getting them a different way than Terraform, such as VirtualBox, then there's no problem, you can just go and do that. We're going to use the same two servers as the last section from now on, so we don't need to alter our Terraform, we can just go straight ahead and run and apply. As you can see, my apply is saying nothing changed because I didn't even spin them down last time. Actually, it's worth me mentioning that aside from the cost savings, there are actually other benefits to always spinning your servers down when doing these courses, as if things go wrong or you have a little play around with them, they may be left in an odd state that give you different results to me in later sections when you're running through the examples. I'm not spinning mine down every time, purely because I'm filming several of these courses back to back, but I would recommend you spin yours down at the end of every section, both to save money and for the cleanliness of having a new server every time. I'm just going to make a note of these IPs, and then jump over to my hosts file to confirm that they match still. And yep, they look about the same to me, so I'm good to go. So far, we haven't gone to the trouble of creating any names for these machines, as putting a fully functioning DNS solution in, which is most likely what you'd see used in industry, is a bit more effort than it's worth just for these courses. For this section though, we do want our machines to have names, and conveniently we can add these as aliases in the inventory itself by writing a name in front of this IP like so, and then prefixing the IP address with the words Ansible_host. This isn't something I've ever really seen done in the workplace, as the existence of DNS does the same job but better, and unlike DNS, this setup I've got here wouldn't dynamically update if I changed my IPs, it's statically hard-coded into the inventory. But as a quick way to attach names to the IPs we happen to have right now, it's perfect, and we're going to need that soon, as you'll see shortly. I'm also going to now specify a variable and its value here, as the inventory is the first of the places we can put variables. I'm going to write the word port here and give it the value of 80. Now let's do a similar thing with DB, only in this case I'll use the port value of 3306 for the MySQL default port. Just to clarify at this early stage then, we have two groups now, Web and DB, and we have one server in each group. Web1 lives in the Web group and DB1 lives in the DB group. Right, let's expand out our roles we made in the last section. Inside main.yml in the DB roles tasks folder, I'm going to edit the destination port for this firewall rule so that instead of using a hard-coded value, it now references the variable we've just created. In Ansible, variables are written as two curly brackets surrounding our variable name here like this. As you might guess then, this curly bracket statement is going to be substituted by the value of the variable we declared in the inventory, which for DB1 was 3306. Now I'm going to repeat this process in the web tasks main.yml, And because we defined this variable to be a different value for Web 1, in this case we'd expect it to be substituted for port 80, which is what we want. OK, great, let's give that a quick test. I'll change back into the terminal, browse to section 5, and run our standard Ansible-playbook -i hosts playbook_web.yml. Excellent, that's run through nicely. You can see here the message warning me it's automatically converting my integer to a string has come back. This isn't a problem, as that's what we want to happen, but it's making our run look a bit messy. What's more is a great opportunity to show a nice trick to solve it. If we jump back to our main file in VS Code, we can actually explicitly define what type the variable is by adding a downwards pipe here, and then the word string to say, this variable is going to be a string. If you can't find the downwards pipe on your keyboard, on mine it's at the bottom left next to the Z key. I'll just do another quick fast-forwarded run of that playbook to show you that the warning message has now disappeared. Great, it's disappeared. OK, so we've defined some variables in our inventory file directly, and they're working. With only 2 hosts and 1 variable in each host, this is fine, but it might get a little bit messy if we had 5,000 hosts and 100 variables per host. So we're going to need a better place to put them if they're in bulk. The first place we're going to look at doing this is the host VARs directory. This lives in the root of the Ansible folder, so let's create one now here and call it host_vars. As you can probably guess from the name, this folder will apply its variables at the host level. Ansible will look inside this folder for any files whose name matches to that of one of the servers to which we will be applying configuration. As we have hosts called db1 and web1, let's create 2 files in here then, called db1 and web1 respectively. You can probably see now why we needed to add those aliases to give our hosts names for this section. Inside the web1 file, I'm going to write port, and as this file is YAML, I'm also going to write a colon, then the number 80. Also as it's YAML, I'll pop 3 dashes at the top. And now let's do the same for the db1 file, but of course this time use port 3306. Finally, let's jump back to our hosts file and remove the port values that we've put in there so that they don't interfere with anything later. OK, great. So now we're defining the same port values, but we've got them in individual files away from the inventory in a folder called host_vars. Let's run our Ansible command again here and see what happens. As you probably expected, it's run through and it's still functioning the same. As predictably enough, it's now picking up the web1 file and applying the variables in it to the web1 host. And had I run the DB playbook, it would have applied the db1 file variables to the db1 host. That's pretty useful then, as now we've abstracted our variables away to a separate file, just like we did when we used the terraform.tf_vars file in Terraform. Abstracting variables away like this is nice, as it gives us a one-stop location for all values in case we want to change something, without having to dig through the code. It's neat and it's tidy and it's easy to read. This isn't the only place we can store variables in file format though. We could also create a folder called group_vars like this, and as you might well have guessed, any files in the folder that match the name of a group will then be used to provide variables to the hosts in that group. So in our case, we have a group called web and a group called db. So I could create a file here like this called web, and again write our dashes. I'm actually going to write port 81 here, and this will now apply to all hosts that are under the web group. Even though I'll just be demoing web at the moment, let's do the same with db here for completeness. Right, let's go back to the terminal and take this for a spin with our Ansible-playbook command. As I've changed the port to 81, we might now expect to see the output say changed rather than just OK, as I'll be adding a new firewall rule to the server at 81, right? But now we see the result, it doesn't say changed, it still says OK. This is because host_vars are taking precedence over group_vars, and at the moment we have defined variables in both. I wanted to actually show this to underline what precedence is. is if we do happen to be defining the same variable in multiple places, we'll only ever be able to apply the most precedent value. In this case, host_vars wins, which is still defined as port equals 80, so nothing has changed. Let's do something about that then, and delete the web1 file from host vars. Now, as there is no host-specific file, the variables in group vars for the web have free rein and will be able to apply. So if we run the Ansible playbook again, there we go. Now it's saying changed because it's added our new firewall rule at port 81. A common mistake that can be made when using Ansible is to look at something that says changed and assume that it's changed it. To elaborate on this, we might now look at this output and think it's changed our allow port 80 firewall rule to an allow port 81 firewall rule, but that's not what's actually happened here. If I SSH into this server to illustrate this, let's just get that actual IP here. There we go. Now I'm connected into the server we've just made those Ansible changes on. I'll switch to the root user here and let's take a look inside the firewall. You can see there's a rule for both port 80 and port 81, even though our Ansible only specifies one rule in the task. The word changed meant that Ansible had made a change to the server, which in this case is to add the firewall rule for port 81. It didn't remove the existing 80 rule or change the existing rule from 80 to 81, because that's not what we wrote in our task. We wrote add a rule for the following port, so when it saw that that rule wasn't there, it just added it. The rule for 80 will still be there, and also will remain there until we go and remove it, if that's what we want. So changed referred to the fact that something new had been done, but it doesn't actually mean I've gone and changed the thing the way you might imagine. It will have just done again whatever is in the task. This is a key difference between Ansible and Terraform's take on idempotency. They are both idempotent in the sense that if you run the same Ansible or Terraform code, it will always give you the same result, regardless of how many times you run it. But in the case of Ansible, the starting state of the entire server does make a difference, so perhaps it's not truly as idempotent as Terraform. Terraform will absolutely enforce whatever you have in your code, and if there is an extra server in the cloud or an extra bit of gubbins that isn't in your code, Terraform will delete it, assuming that it had been created by Terraform in the first place, of course. Ansible will idempotently apply tasks, but the idempotency is limited to within each task. It doesn't go and scan every possible aspect of installed software and firewall rules and updates and all the rest of it, and then enforce some kind of template that will make all of those things happen. It just makes sure each task you define has been applied, and is in the state you ask it to be, but no more. There are two key ways you can get around this being a problem. The first way is to design your Ansible rules to be self-cleaning. So for example, it would be possible for me to write Ansible that would delete any firewall rules not explicitly defined by Ansible itself. I wouldn't actually recommend ever doing this though, even though I've seen it done in industry, as this can often have odd side effects when I've seen people attempt it. And the second method is so much easier in any case. The second method to get around this problem is just delete your server every single time you make any changes and rebuild the entire thing from scratch. So to use the example of our firewall change here, when I changed the variable to port 81, instead of just applying Ansible, I would delete the entire server, respin it up in Terraform, and then reapply the Ansible. This might seem rather extreme behaviour for just a simple port change, but in fact, behaving this way is highly beneficial to the robustness and health of the estate. Firstly, by spinning up a server from scratch regularly, it shows that everything required for that server to work is contained and automated in the creation process. If for some reason you do have a rogue, old-school engineer who likes to go in and make the occasional manual change to a server, constantly deleting and recreating those servers will soon highlight this and prevent him doing it any further. Secondly, the kind of system design that allows for servers to be deleted indiscriminately and recreated at will without downtime will require excellent architectural practice, especially in terms of load-balanced high availability design, which will make the estate ever more resilient to the accidental or fault-related disappearance of those same servers. For instance, in AWS, perhaps you might run two identical estates in different availability zones for resiliency. that is as effective during an outage as it is during the automated recycle of some particular service. Anyway, let's exit out of this for now and do a bit of cleanup by deleting these host var and group var files. The next place we're going to look at creating variables is inside the role itself. If you remember the last section, we had a look at this expanded role structure with a list of the possible folders you might expect to find in a role. Well, in this folder list, 2 of these folders deal with variables, the defaults folder and the VARs folder. Let's start by creating a default folder in each of our roles then. And in each defaults folder, I'm going to create a file called main.yml. So one in web, one in the DB role, and one in the common role. Starting in the common role this time, if I open the main.yml in tasks here, you can see that currently we're just installing Vim as a randomly chosen package we might feasibly want on all of our servers. If we wanted to install a few more things as part of our common role, we could copy and paste that whole block a few times and change the word Vim to different things, such as nettools or TCP dump or whatever. Variables can provide us a neater way to do this though. Let's go to default here and define a variable called install_packages. Unlike with port, where we just had one value, I'm going to create a list of key value pairs under this heading, with the key name and then the value of the package I want installed. So I'm going to say name Vim, then name nettools, and then name TCP dump. Of course, most companies wouldn't really want to install TCP dump in their common role on every single server. It's just a package whose name easily sprang to mind for me. Now we've created that list, let's switch back to the common tasks main.yml, and we're going to add a new heading here at the bottom of the task called with_items, which will cause this task to loop through a list such as the one we've created. And of course, we're going to write install_packages in here as the variable we just made. Now up here, we're going to change Vim to another variable, and in here we write item.name. So what we're doing is we're saying loop through the list in install_packages, and for each item in that list, use the name value here. Lastly, let's quickly go and populate the defaults of DB and web with the appropriate port numbers. So port 80 there, and there, port 3306. OK, let's give this new setup a whirl and check that works. We can see it applying each of those packages there, though it's saying OK rather than changed, as I've actually got these packages installed already. But nonetheless, it's definitely working. Using variable lists in this way is Ansible bread and butter and well worth committing to memory. You'd use this constantly in an Ansible heavy role. This is a way to use a very small amount of code to perform an idempotent install of literally any package that we add to that list, which is a great brief way to configure a server with all the bits we're going to need. As I mentioned, defaults isn't the only place we can specify variables inside the role though. Let's create a new directory called VARs, and again I'll create a main.yml file inside it. As you might expect, VARs stands for variables and takes precedence over defaults. This makes sense to me as the term default implies a value you get by default, only if nothing else overwrites it, so you'd expect it to be quite far down the precedence list. We don't need to dwell on the VARs folder too much as it works exactly the same as defaults, so I'll quickly cut and paste the list from defaults, and to illustrate its taking precedence, I'll just add nano to the end here, and then we'll run it again using the Ansible playbook command. And lo and behold, just as you'd expect, we can see that nano is also included as the VARs folder is taking that precedence over the default folder. As I said, when I started making this section, the length of time required to cover the basics of variables did somewhat take me by surprise. And I don't want to drown you in boring different examples of ways you can apply a variable, as you'll be able to find them all yourself now you've got the basic idea. But that being said, there is just one more quick usage I'd like to go through here, which will bring in another standard folder to the roles structure. If I jump back to Visual Studio Code, I'll just quickly minimize a few things here to neaten up the view a bit, and then I'm going to create a folder in the common role called Files. The Files folder in a role is used for storing general purpose files that need to be copied as is to a server. This is as opposed to a template, which we'll be covering later, which contains variables that get substituted for different values before copying. You might use that for a config or something similar. Things that are stored in the Files folder are for copying direct and unaltered. A common example of this might be an SSL certificate that could be copied to every web server in a farm. But in this case, I'm just going to make a file called Wibble, and inside it I'll just add some test data so that we can recognise it. Now, in my defaults main YML, I'm going to add a new list of key value pairs called test_files. In our first list, each list item had only one key value pair, that of name and its value. In this case, each list item is going to have two keys, each with a value. File, which represents the file local path, and remote path, which represents the remote path to copy the file to. I could have called these anything, by the way. Variables can always be named anything. This is just my habitual name for these. You can see here I've chosen remote path to be /home/ubuntu/wibble, which should hopefully copy this into the Ubuntu user's home directory on the server with the same name of Wibble. We're now going to need to add a corresponding copy task to make use of this variable. So I'm going to go back to the task's main.yml of the common role. I'm going to give the task a name. I'm going to choose the module copy, then the parameters are source, destination, and mode, which is the permissions on the file. And finally, I'm going to specify the items that it should get these values from. In this case, there is only one file, so I didn't have to make a list of key value pairs like this. I could have just had two variables. But generally in deployments, you'll be copying several files or templates over, and you can just use the one copy task for all of them and then iterate over a big list of key value pairs. So it makes for much more condensed Ansible, and I wanted to show it to you in this format. As always then, let's run the playbook to confirm it's all working. Sure enough, it says changed. But as this is nice and easy to check, let's actually SSH into the server here and confirm the file is actually there. I'll do a quick list, and there we can see our Wibble file. And as expected, it's got the right contents. I don't know about you, but I think that's all I can take on this incredibly useful, but perhaps not that fascinating subject of variables. One final comment I'd like to make is that a full list of variable precedents can be found on the Ansible website. It looks like this, but I wouldn't recommend you bother learning this unless you actually need it. When you make a project, you'll probably decide based on the conventions of the business you happen to be in where the variables will live, and that choice will be affected by such factors as the orchestration system that they're using to run it, or how they've implemented it. Just being aware that this list is available online if you ever do need it is probably enough. Finally then, let's behave like DevOps professionals by checking our code back into Git. So, cd back to the root of the repo, git status, git add a, git commit with a sensible message, and then git push origin master. Nice work for getting through such a long section. When I make these videos, I'm often imagining someone who has a job interview in 2 weeks' time for the thing that they're studying, so I try and cram in quite a lot of knowledge into what's a comparatively short series, bearing in mind the size of concept like Ansible. So I would say, at this point, now we've got a load of the basics down, if you've got time, maybe go and have a little play around with what we've learned so far, and go and do a couple of things for yourself and see what you can spin up. If you haven't got time and you are about to jump into that job interview though, then let's sweep straight on to having a look at templates in the next section, a super useful tool for adding things like configs to our environment. Hopefully see you there.